This skill module covers separation at the core knowledge level. This section discusses why this topic is important. Separators are a critical but often overlooked component in a processing facility. Applications range from bulk separation of produced fluids to gas scrubbing upstream of compressors, dehydrators, and amine systems. Poor separator performance can significantly impair the effectiveness and availability of downstream process equipment, which in turn reduces profitability. This skill module provides an overview of separation principles, applications, and sizing techniques. Many types of equipment cannot handle a wide range of operating conditions and/or separation requirements. As a result, it is often necessary to use more than one type of separator for a particular application. Sizing and selection of an inlet production separator requires handling of intermittent flow. Difficulty is in characterization of the inlet flow, that is, gas and liquid flow rates, as a function of time that need to evaluate the upstream supply. Inadequately sized separators will experience frequent level alarms and shutdowns, and also, by necessity, pass the surges downstream, leading to unstable operation. The typical response is to restrict inlet flow, which costs a big loss of revenue. Understanding the main components and configurations of separators and their purpose is helpful to understanding how gravity two-phase separators work. The first place that separator performance is impacted is in the inlet piping and inlet device sizing and selection. By understanding the recommended guidelines around inlet piping design for separators can help ensure the piping to the separator equipment will reduce the kinetic energy of the fluids, minimize two-phase flow shear, and start preconditioning the two-phase flow to optimize separator performance. There are multiple types of inlet devices that can be selected for gas-liquid separators. Understanding their performance and what applications they are selected for can help ensure that the inlet device that is selected is appropriate for the required separator performance. The mist extractor is the final gas cleaning device in conventional separators. Understanding the different types of mist extraction devices and their common applications is important for proper mist extraction device selection. In addition, understanding their typical performance parameters can allow one to troubleshoot their operation once they are installed in the field. The various mist extraction devices have different liquid droplet removal efficiencies as well as different liquid handling capacities. They also have limits in terms of turndown, as many of the devices separate the liquids for the vapor by impaction on a metal wire or vane. The primary operating limits of the separation internals should be known to allow for the proper selection of a mist extraction device for a separator application and to allow for troubleshooting performance issues in the field. The first step of separator selection is determining the separator orientation, vertical or horizontal. Vertical separators are generally selected for gas-dominated separator applications. A lot of gas, not a lot of liquid. Horizontal separators are generally selected for liquid-dominated separator applications. A lot of liquid, not a lot of gas. Understanding the parameters that govern separator sizing is important when purchasing a new separator or when trying to troubleshoot an existing separator in the field. Understanding how to estimate the required diameter of a separator for a given application will allow one to confidently review vendors' bid packages to ensure that the vendor quotes will meet the required stated performance for a conventional vapor-liquid separator application. This skill module discusses the topics shown here. You may also be interested in these gas conditioning and processing principles skill modules.